Evening, everyone. I was just recording or starting to create a lesson for my cohort, my group of students that I'm tutoring, my 8 legends, and I came across something that a lot of students find difficult, so I just thought I would give some input for that so that everyone in the group can benefit, and that is tectonic hazards and plate margins. There are 4 plate margins that students need to be aware of, and this crops up in the physical exam or the physical part of the exam, depending on what exam board your students are with, but it's like most people in the group are with AQA. So the first thing people need to know is what causes tectonic plates to move in the first place, and this idea that the Earth's crust is split into tectonic plates. We are part of the Eurasian plate, which is Europe and Asia, which is quite a large tectonic plate. Other significant ones are things like the Pacific plate. That's the largest plate in the world, okay? And depending on which direction these plates are moving and how they interact with each other will lead to things like earthquakes and volcanoes. So students need to know that there are 4 types of plate margin. Called different things depending on which exam board. AQA tends to use destructive, constructive, conservative, and collision. If you're Edexcel, you might use convergent and divergent and conservative. So starting with a destructive plate margin, so you can see that we've got 2 plates colliding here. One is oceanic and one is continental. The oceanic plate is more dense, so it's kind of heavier, and therefore, as they collide, it sinks and subducts beneath the continental plate. And that is bad news. It's called destructive for a reason. As it subducts, the plate melts, okay, and all that magma rises through the crust and forms strato or composite volcanoes. And these are the big, scary volcanoes like Mount Vesuvius, which can cause a lot of damage. As the plate subducts as well, there's friction. You're going to hear this word used quite a lot. With the other plate, and friction builds and builds and pressure builds. There's tension, there's pressure, and eventually the plate will slip, and that will trigger a massive earthquake. And if that happens underwater, it will cause a tsunami. Okay, so that is a destructive plate margin. You'll also get oceanic trenches like the Mariana Trench forming as a result of that. So as I said, these are the big scary ones, and the main thing students need to know is it involves an oceanic and a continental plate. Okay, and there's just some keywords there, but I've covered all of those. So that's absolutely fine. An example would be the Pacific Ring of Fire. The Pacific plate is the largest plate. It's an oceanic plate, and where it touches all the other plates around it, it's sinking beneath them, creating land like Japan and lots of volcanic islands like the Philippines and places like that. And there's lots of volcanic activity all around the Pacific Ring of Fire. The next one is a constructive plate or a divergent plate. And as the name states, these are plates diverging, so they're spreading apart. And as the plates spread apart, all the magma in the mantle beneath can rise up through the gaps. This can lead to shield volcanoes, which are more of a shield shape, hence the name. They're not as destructive. This is what's going on in Iceland right now, because as the Eurasian plate and the North American plate are moving apart at a rate of 3 centimeters a year, that's causing the magma to rise up through the gap. So we've got that lovely eruption going on in Iceland right now. The lava is less viscous, which means it's not very sticky, so it doesn't stick to the sides, making a steep volcano. And because of that, there's not a lot of pressure building, there's not a lot of gas being trapped, it's just kind of oozing out. I think of it as a bottle of fizzy that's shaken, but the lid is off slightly so the gas can escape, whereas a destructive one that we did that just a minute ago, imagine the lid is on, you shake it, and then you quickly release it. That's why they're really explosive, where these ones are a lot calmer, but the ash can be quite a problem. Okay, so this is what's going on in Iceland. You do get earthquakes here as well, so there's always going to be friction and pressure and slipping, and that will trigger earthquakes. An example would be the Mid-Atlantic Ridge, and that's the one that's closest to us, and that is responsible for places like Iceland and the Azores further down off the coast of Portugal as well. We then have a collision plate margin, which is very similar to a destructive, but this time, as you can see, they're both continental crust. Okay, so one with the other volcanoes, with the other plate margin destructive, one had to be oceanic, so it could subduct and sink, but these two are the same density, so as they collide, they literally just fold upwards. They push up to form fold mountains. And again, we're going to get earthquakes, we're going to get tension and pressure and impact. We're not going to get any volcanoes. There's no melting happening here. There's no gaps. We're just going to get fold mountains and earthquakes. And the Himalayas is a really good example of this. So, bit of trivia, Mount Everest is getting bigger every single year as those 2 continental plates are colliding and pushing up making it taller and taller each year. And it's been responsible for some massive earthquakes in the past, like in Nepal, which killed about 6,000 people. And the final one is a conservative plate margin. So on this one, you've got two plates rubbing side by side. And that's friction. If you rub your hands together now, really sort of with quite a lot of force, they're getting warmer. And there's friction building and building, and eventually it's going to slip. And that slipping, that jolting, is what triggers the earthquake. Okay, down in the crust where you feel it most is going to be the focus, and on the surface you're going to have the epicenter. Students can remember that, but if they draw an F with an arrow pointing down, it's down for the focus, and an E pointing upwards for the epicenter. And then seismic waves are released from that epicenter and focus, and that's what the shaking is, which causes, or which the people can feel. Again, if this is off the coast, it's going to trigger a tsunami. A really good example would be the San Andreas Fault in California. I think The Rock or Dwayne Johnson made a film called San Andreas, which was an exaggerated version, but you get the idea. These do trigger big tsunamis if they're off the coast. Okay, so they are the 4 plate margins. I hope that helps. Students need to be able to draw them, and they need to be able to explain the hazards that they create, whether they're volcanoes or earthquakes, and they need to know specifically what direction the plates are moving. Okay, I hope that helps. Look after yourselves, and if you've got any questions at all, give me a shout. Cheers.